Here's a little bit of homework help for Unit 5, Lesson 17. What we're after with this thing is, what we're after here is we're talking about scaling in one dimension. So this is actually a lot simpler than it may seem at first. So here we go. What we're after with this, we know that we have a cylinder that has a volume of 48 times pi cubic centimeters and a height of h. We're supposed to complete this table for the volume of the cylinders with the same radius, so the radius is not changing, but different heights. That's the only thing that's changing. What we know right now is how to find the volume of a cylinder, which is pi times the area of the base, which is a circle, so pi times the radius squared times h. Given that information, I'm supposed to figure out from here what my volume would be if it's equal to pi times the radius squared times the height. But what we know about this is the height is going to change just a little bit. It's going to be twice the height. Now with that information, it might seem like this is unreasonable to be able to figure this out, but we have to also remember they gave us a place to start. So it's given that we have a volume of this cylinder is 48 times pi is equal to pi times the radius squared times h, which is our height of h. The only thing that's changing as we do this is we're going to multiply the height by 2. What that does is that in effect changes, if I multiply this side over here by 2, or multiply the height by 2, it effectively multiplies the entire expression on the right by 2. And by that opportunity, by increasing the height by 2, excuse me a second, with this understanding, if we understand that we're multiplying 2 by the height, we're in effect multiplying everything by 2, which means by the properties of equality, I would double the volume of that figure just by doubling the height of it, which means that box A, would end up having a total volume of twice as much cubic centimeters as the original. And then as we go on and we look at each of these, this one, part B, would have 5 times the total volume, right? So 5 times 48 times pi. And then this one would be half the total volume, and then 1/5 the total volume. I hope that that's helpful in letting you know how to do this, or reminding you how to do this. Just a simple portion on this scaling in one dimension. Scaling meaning increasing in size or decreasing in size by a proportional value. And with this, we're actually taking, by doubling the height, we're doubling the volume. By multiplying the height by 5, we're also multiplying the volume by 5. Half of the height makes half of the volume. 1/5 of the height makes 1/5 of the volume. All right, let's look at the next one here real quick. You'll answer that in all these different parts here. And then we'll get on here to the next problem. For this next problem, we're talking about, again, another cylinder that has a radius of 3 centimeters and a height of 5 centimeters. So the very first thing we want to do is find that volume. Remember that volume is going to be the area of the base, which is a circle, multiplied by our height. And so when we're working with these pieces, all we have to do is substitute our values. We see that R is going to be 3 and H is going to be 5. So volume is equal to pi times the radius of 3 squared times the height of 5. So we'll be working on that one as 9 times 5, or 45 pi. Remember that we're writing the value of pi as p times I. You'll continue to use the same pattern of substitution with the given values to be able to determine what the next volume, or what the volume will be. As we look at, wrong button. As we look at the next part of this, part B, it says what is the volume of the cylinder when the height is tripled. So remember, where it says right here, what is the volume of the cylinder, you're going to continue to use the same dimensions that were given up here above. So the radius continues to be 3 centimeters, and then are comparing radius of 3 centimeters, height of 5 centimeters. So when we go to the next problem, we're saying what is the volume of the cylinder when the height is tripled, we have to consider that piece that we're still looking at a radius is 3 units, but now our height, which was 5 units, is now being tripled. So our height has to be 15. This tends to step into, or this only changes one aspect of our volume of our cylinder. So you start out with a cylinder that's approximately this big and has a total volume of 45 pi cubic units, or cubic centimeters. Then we look at this on the spectrum of 3 times taller. So we have that cylinder once, and then again, and again, in the respect of 3 of those cylinders, just as one great big cylinder. So we have to consider that fact that we have 45 times pi in each of these cylinders. And recognize how that measurement, or changing just that one factor of the height, tripling the height, how that affects the overall total volume. You'll see that again in part C when we talk about the volume of the cylinder when its height is cut in half. So the only thing we'll change is when we substitute the value of the height, we'll take half of 5. And then we'll see the same thing in part D, or excuse me, there is no part D, just kidding. So, but remember, answer your questions in terms of pi. The next question talks about a graduated cylinder that is 24 centimeters tall and can hold 1 liter of water. Remember that 1 liter is equal to 1,000 milliliters. So what is the radius of the cylinder? Take the information that we know, that the cylinder is 24 centimeters tall. So let's talk about the volume with respect to the formula for the volume of a cylinder. And then let's look at what we know. We know that it is 24 centimeters tall. So here's our height of 24. Of course, we'll have pi. We do not know what the radius is currently, but we do know that the volume is equal to 1 liter. So we're going to have to figure out something here. We can't say that our volume is totally understood as far as what it would be with regard to cubic centimeters until we do a little bit of division. So we talk about the overall, the total volume, that 1 liter, how many cubic centimeters are there in 1 liter? You can go ahead and Google that, or you can go ahead and take the information that's given here, and we find out that we have 1,000 milliliters would have to fit into this equation somewhere. So our total volume is 1,000 milliliters. But we have to see again, how does that compare when we're talking about 24 centimeters tall? They're not the same unit measures. And so we have to consider that option when we, with regard to figuring out the radius based on 2 different unit measures. To figure that out, we need to get the radius ultimately by itself. To do that, we need to divide out 2 different factors. We need to divide out the 24 and the pi. 24 divided by 24 is 1. Pi divided by pi is 1. So we need 24 pi as the divisor to 1,000. When we have that value, that will help us to know what the radius is squared. In approximate values. And with that value, we should find the square root of it as well to tell us what the radius is. Round your answer to the nearest hundredth place, please. After we find this, you'll have to use that same kind of information when we talk about the 500 milliliter mark, which would be half of the total volume. And then in part C, we talked about the 250 milliliter mark, which would be 1/4 of the total volume of 1,000. The next one talks about an ice cream shop offering ice cream cones. The waffle cone holds 12 ounces and is 5 inches tall. So consider what a waffle cone would look like. And that the total volume here is 12 ounces. And that the height is equal to 5 inches. The sugar cone, something a little bit different, but it's really the same thing. Just a different material, holds volume is 12 ounces. But its height is 8 inches. So a little bit different in the height. Which cone has the larger radius? So you'll have to be able to work through that and kind of decide which one must have larger radius based on the information, the volume, and the heights that are given. You can set those up into the formula for a cone. For a volume, remember that a volume of a cone is 1/3 the volume of a cylinder. So that might be helpful to you, or you can try and do this through some logic. The next question talks about a paper cup that's shaped like a cone with a diameter of 4 inches. Pay attention to that piece right there, because that diameter of 4 inches on the cone is talking about, on the cup is talking about all the way across. So how many inches of water, how many ounces of water will a plastic cylindrical cup with a diameter of 4 inches hold if it's the same height as the paper cup? So this goes back to previous lessons, comparing another cup that's in a cylinder shape that has the same diameter and has the same volume, has the same, that holds the same height. So we have to figure out that piece. Don't include ounces in there. Recognize that you're really looking at this piece about the total volume here is 6 ounces. How many ounces right here, with the understanding of the concepts of volume of a cone when it has the same diameter and the same height. I know I'm not really giving you a whole lot there, but it does have something to do with recognizing the difference between the formulas for volume on each of these. So pay close attention to that. That's it for your homework, just those problems. Thanks for tuning into this video. Apologize for my voice. Hopefully it'll be back to normal soon. Take care.